In this tutorial, you'll learn about the new Autodesk Ray Tracer, or ART, renderer. ART is a physically based renderer that is fast and easy to set up, as it has minimal settings and a very short learning curve. ART renderer is compatible with many 3ds Max features out of the box, but is optimized to work particularly well with some specific ones. You will explore these in the scene named denart.max. A download link to this file is available in the description section of this movie. As the name implies, the scene shows a den or family room, albeit with some objects hidden from view at this time. If you set your Scene Explorer to Layers, you'll see that furniture, plants, and other props have been temporarily turned off to simplify the scene. The scene currently doesn't include any lights, but does have 3 cameras. These are based on physical cameras that you are encouraged to use instead of standard cameras, as they give you more and better options. Other than that, the materials applied to the various objects are based on the new physical material. This is a new material type that is also easy to set up and is particularly suited to work well with the ART renderer. To learn more about the physical material and how to set it up, watch the tutorial named Understanding the Physical Material on this channel. To set the Autodesk Ray Tracer as a rendering engine, you use the familiar method. In the Render Settings dialog, switch the current renderer to the new ART renderer option. Apart from the Common tab, which you are already familiar with, there are only 2 tabs to worry about. Only one of those contains parameters for the rendering engine. It is also a very short panel with very few parameters to worry about, which makes this renderer one of the easiest to use. Currently, the render quality is set to draft, which is about 20%. Leave that current. You'll come back and explore more of these options in a moment. First, you need to add a few lights to the scene. You'll start by adding sunlight using the new Sun Positioner. The Sun Positioner works like the daylight system you're already familiar with, but is easier to set up and use, and is optimized to work well with the new ART renderer. Also, you'll find the Sun Positioner in the Lights panel, which is easier and more logical than to hunt for it in the Systems panel. The creation of the Sun Positioner is somewhat similar to the creation of a daylight system, though, and is done with a series of clicks and drags. These determine the main position of the compass and its size, the north direction, and the sun distance. One nice thing about the Sun Positioner is that all its parameters are viewed in the Modify panel. This means you don't need to jump back and forth between the Modify and the Motion panels to edit properties. Parameters such as time of day and geographical locations can be edited as before. To change the north direction, you can simply rotate the compass directly in the top view. If you prefer to keep it simple, you can also expand the Sun Positioner entry in the Modify panel and select Sun. This puts you in manual mode, and you can position the sun exactly where you need it. Open the Environment dialog by pressing 8. Note that when you add a Sun Positioner to the scene, the system automatically adds a sun and sky environment, and also sets the exposure control option to use physical camera exposure control. This was done automatically, and without any redundant prompts you routinely answer yes to. If you reset exposure control, and even clear the background altogether, you can restore these values without doing it manually. You only need to use the Install Sun and Sky Environment button found in the Modify panel. If you do so, always verify that the Use Physical Camera Controls if available option is active. In fact, I'm in the habit of disabling and re-enabling it to make sure. This ensures exposure control is adjusted at the camera level. Dismiss the Environment dialog and render the camera view to get a feel for the scene. Note the progressive nature of the rendering that gives you instant feedback if you're on the right track. The noise in the rendering can be adjusted with rendering controls, as you'll see in a moment, but draft mode works well for test renders. At any time, you can stop the rendering. To illuminate the interior a bit more, you have a couple of options. One option is to change the camera exposure. Try a value of 6 to see the results. The interior is certainly brighter, but the exterior is now washed out. You can compensate by darkening the outside texture or simply by adding interior lights. If you decide to add interior lights, you can do so in a couple of different ways. You can either use actual light objects, or you can use mesh objects with emissive materials applied to them. Set the camera back to an EV value of 9 or 10. Merge the file named Interior Lights you downloaded for this tutorial. When prompted, merge only the photometric light objects into the scene. These are the same photometric light types that you've known and used with Mentor Ray before, and they work equally well with art. An alternative, as mentioned, is to use an emissive material on objects. Delete the lights you have just added and instead merge in the bulb objects from the same file you used before. These are editable poly objects that don't have a material assigned to them just yet. Open the Slate Material Editor and create a new physical material. Double-click to view its properties. Set the emission value to 1 and boost the luminance value by quite a bit since the individual objects are quite small. Set the luminance value to about 150,000 and apply the material to the bulbs. Test render again. Try other luminance values and even color temperature for a different ambiance. Once you're happy with the preliminary results, unhide the rest of the scene and try a test render again. Next, you take a look at Art Render Quality Controls. To that effect, make sure the Render Settings dialog is open and that you are in the Art Render tab. The first slider is arguably the most important. It lets you set the overall quality of the rendering. The default is set to 20% or 20 decibels, which is conveniently a noise level unit. The higher the value, the better the solution, but higher values mean longer render times. An alternative is to set the slider to a higher value for better quality, but force the system to stop rendering after a landmark is reached. That mark can be set as a time unit, or as a number of iterations. Another measure of quality is the drop-down menu that lets you choose between Fast Path Tracing and Advanced Path Tracing. While Fast Path Tracing may yield excellent results for most scenes, Advanced Path Tracing extends rendering time while providing better solutions. Their pros and cons are listed in bulleted form in the panel. Finally, there is a noise filtering option that you can use to reduce the noise level in the final render. This can be very useful to reduce noise, but you have to be careful that it doesn't remove detail in the process. To test it out, set the quality to draft mode again at 20 decibels, and make sure stop rendering is not active. Enable filtering and set it to 100% or fully filtered. Test render again. The filtering is a post-rendering process and is only applied after the scene is rendered in full. In this case, it may take a minute or two. Note that while the noisy grain is totally gone, so goes with it a fair amount of detail in the render. The wood grain on the beam certainly seems less detailed. Still, this may be more than satisfactory for a test render. Alternatively, you can fine-tune the render values for a balance that you like. Try 22 decibel quality and 55% filter strength. This should give you a good average between rendering speed, quality, noise, and detail. Try test rendering other camera views. Keep in mind that once you're satisfied with the overall look, you can boost the quality of the rendering for even better results.